Okay. For those of you watching at home, I forgot to start the camera. Internal energy we're talking about. All you guys are sitting out there bored because I'm going to say the same thing again. All the energy is contained within a substance, internal energy, delta E takes into account. All right, you may have to pause this, so if you're at home copying this. Emily, you may have to pause this. Hey, locals out here. And copy these notes down because I'm going to go through them very quickly. It's the kind of, what I was just saying was it's kind of like when Mr. Schrader was doing your M&M experiment. He was only measuring how high you moved up and down in the box, not how hot your body got. Okay? This includes both. We have been concentrating on the heat energy in this class for the past 3 weeks. Mr. Schrader concentrates on only the kinetic energy, you know, how high something is, what the mass of it is, what's the rate it's falling at, how force moved through a distance. Delta E takes both into account. Q being the heat absorbed or released by the system, W being the work done by the system or done on the system. Okay? When it comes to Q, we know already this. This is very simple. We already saw this before. Positive answer for the delta H, when we were calculating delta H's, positive answer meant it was endothermic. All right? Energy was being absorbed by the system. Negative meant exothermic. It was releasing energy. It got hot. But there's another way it can release energy. And there's another way it can absorb energy. Okay? It doesn't have to be by getting hot or cold. It can be through moving this syringe. Okay? So, when we talk about W, that's the work done on or by the system. The first way we'll look at W is positive work, when work is done on the system from its surroundings. So if I push down on this syringe, if I give it energy, like I did with this one a second ago, I can't do it on the camera, I push down really hard, it actually gives enough energy to light that little piece of paper on fire that's down there, all right, in the bottom of that thing, because I'm compressing it, okay? And that's basically what's happening when you have a positive work W, okay? It generally accompanies a volume decrease, a compression of the molecules, all right?
I think the second one was better.
Second one.
For the camera.
It was faster, anyway.
I like that one better.
Okay, good. All right, now, the opposite, of course, is going to be true for a negative delta H. Or, sorry, a negative W. If work is done by the system, I want you to think about this. My example was, I said this to you guys a minute ago. My example was, if I put some baking soda and vinegar into this syringe, and then I close it up. We all know what's going to happen to the syringe. It's the work, the pressure being produced there is going to push that syringe up. It's going to do work. It's going to move a force through a distance. That is the definition of, work, a force moved through a distance. When that happens, it's negative. Just like, energy being released in Q is also negative. They're both consistent. They're both giving off energy. In this case, work is done by the system onto its surroundings, the surroundings being the syringe, okay? And this usually accompanies a volume increase. There's going to be an expansion. There's going to be more molecules of gas formed when you do this. And those are the kind of questions I'm going to ask you on the test. I'm only going to probably, looks like I have time to cover this part of it. There is a bonus part I will kind of hint at a little bit as well. But let's apply all this. I know I went a little fast for the people on the camera, but the other people already saw it. We're sitting here. You can pause it and copy this if you didn't get it all copied, and then just listen to it again. All right, but let's see how I can ask questions, okay? One way I could ask a question is just like this. I don't have an example of this because it's kind of easy, all right? If I told you I had this, if I had H2, don't have to copy this down, all right? H2O gas breaking up into H2 gas plus O2 gas, okay? What would I need for coefficients of balance? This guy, a 2 here and what? A 2 there, right? Everybody agree? Okay. My question could simply be as easy as this. These are all gases. That's a G, and that's a G. These are all gases. If I put all that into a closed container, what would happen to the size of the container? Remembering that moles of gas and volume are proportional. Remember my box of 22.4 liters. Remember that box I used all year last year? Remember that? 1 mole is 22.4 liters of any gas. And so they're proportional at STP. So they're proportional. So what did I do? I went from 2 moles of a gas to 3 moles of a gas, didn't I? So the volume is going to have increased. Work was going to have been done by the system onto its surroundings. It's going to have pushed this guy up, right? So what value would that have, positive or negative, if work is done on the work is done by the system onto the surroundings? What's that value going to be? Negative. So if I'm going to find the W in this guy, he's going to be negative. Now, that's the only kind of question I might ask on the test. It's not, I'm going to give you another one in a second. But that's one of the kinds of questions I'm going to ask you. It's one of the kinds you might see on the AP exam. Is work being done by or on the system? You simply look at the number of moles of gaseous, and by the way, it must be gaseous reactants that are doing the work. Okay? Are you getting more of them or less of them? Another kind of question I can ask you would be something like this one. Copy this down quickly. There's only about 3 minutes before the bell rings. Or I give you actual values of energy, and you have to use that equation. I tell you how much energy was absorbed or released by the heat of the system, and how much work was done by or on the system. And you kind of have to, again, use a little bit of common sense and interpret the results. Not the result, but interpret the data that's given to you. You know what the equation is going to be. It's just going to be delta E equals Q plus W, where Q means the energy, the heat energy, and W is the work energy, the physical kinetic energy that's being done, or having done on it. Whichever. In this case, we're going to see which is which. And we're going to apply the proper sign to it. Let's take the heat first. Oh, that's amazing. Let's take the heat first. Okay? Delta E is going to equal Q. Which one of those is obviously the heat energy, the 1750 joules of heat energy? Now, it said it was released, so what value will that be? Negative. And it also says this guy's in kilojoules, this guy's in joules. Let's convert. What would that guy be in kilojoules? 1.75 kilojoules. Okay? Now, the work. What does it say? And by the way, is that a positive or a negative value if it released that? Positive or negative? Negative. So don't forget to put your negative sign in there. Negative 1.75. Now, it said the system performed this work on the surroundings. What value does the 57 kilojoules have? Also, so I'm going to add to it a negative, what? 57 kilojoules, correct? So it's pretty simple. What's your final answer? Negative, well, rounded out to significant figures would be negative 59 kilojoules, correct? That's all you would be doing there. You're just adding the two guys together. It's possible, now in the problem, again, the bell's going to ring in a few minutes, but before it does, before you leave, let me just say a few things. Tomorrow, and I'll remind me to tape this tomorrow, I will show you how we could have harder questions for this. How we can actually calculate the amount of work done by looking at the pressure and volume changes, all right, using what's called PV work. We're going to talk about that tomorrow. I'll try to put it up there, but that will only be as a bonus question. That's why I'm not worried about giving it to you today. I got to it in the other class. I had time. I didn't for you. It won't matter. It's only going to be a bonus question. Your homework over there is 73 for everyone. Your homework is 73 to 75, 77, and 78 on page 600. 73 to 75, 77, and 78. Now tomorrow, in case I forget, the bonus ones will be 79 and 80. They'll be like those questions where you have to actually calculate the amount of PV work being done. All right?